Hi friends, here is a nice problem. We have to find last two digits of 11 power 10 minus 1 and 11 power 10 plus 1. This is a very easy problem, just that it looks little tricky. We all know our binomial expansion. What is our binomial expansion? A plus b whole power n equals nc0 a power n b power 0, nc1 a power n minus 1 b power n, nc2 a power n minus 2 b power 2 plus nc n minus 1 a power n and b power n minus 1 and ncn a power 0 b power n. Basically, we start with nc0 and we go up to ncn, and a power it will start with n and goes to 0, and b power it will start with 0 and goes to n. We all know this, right? For example, a plus b whole square. A plus b whole square is nc0 a square b power 0 plus nc1. This is 2. 2c0, 2c1, a power 1, b power 1 plus 2c2, a power 0, b power 1. Right? Sorry, before 2. So 0, 1, 2. NC0, NC1, NC2, NCN basically. We'll start with NC0, NC1 and we'll go up to NCN. 2C0, 2C1, 2C2. Right. And A power will start with the 2 and go till 0. 2, 1, 0. And B power will start with 0 and go till 2. 0, 1, 2. What is this? NC0 is 1 and B power 0 also 1. A square plus 2c1 is 2 and a power 1 b power 1 2ab plus 2c2 is again 2c2 is equal to 2c0 nc0 ncr is ncn minus r. This is also 1. A power 0 is 1 base square. This is a familiar formula, right? Similarly, we can write it for any power. Now this 11 power 10 we can write it as 10 plus 1 whole power 10, right? 11 is 10 plus 1, right? Now, if you write it like this and do this expansion, 10c0, 10 power 10, 1 power 0, 10c1, 10 power 9, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Right, 10 will go, power of 10 will go from 10 to 0. And power of 1 will go from 0 to 0 to 10. So everywhere 1 power 0, 1 power 10, everything is 1. So it doesn't matter. So in the last term there will be 1 without tens. And everywhere else there will be 10 powers. 10 power 10, 10 power 9, 10 power 8, up to 10. Right? 10 square and 10. And there will be some numbers. NC0, 10C0, 10C1, whatever. If you observe all of this, what is 10C9? 10C9 is also 10. This is last one. 10C9 is 10. 10C1 is 10, right? 10C0 is 1. So 10 power 10 plus 10 power 10 into 10 power 9 plus whatever. Right? So every other term will be either power of 2, 10 power 2 some times something, 10 power 3 times something, 10 power 4 times something, up to 10 power 10 times something. So the lowest of that 10C9 to 10. This is also product of 10 and 10. Right. So if you see all of these terms are products of at least last two digits are at least two zeros. Right. There are more zeros on it. 10 power 4 will have four zeros. 10 power 3 will have three zeros. 10 square will also two zeros. And the last one, 10c and 9. This 10c 9 10. This also will have two zeros. 10 into 10. Plus only one left. So this entire term minus 1 will always have last two digits zeros, because whatever this one extra that we are removing here, right? So this is actually becoming as first term having at least 10 zeros or more, second term having 9 zeros or more, so on. The last but one, this also is having at least two zeros, and this one extra we are removing here, right? So this number will always end in two zeros. Last two digits are definitely zeros. We don't know about others, but definitely last two digits are zeros. Right. Now last two digits are zeros. What will happen to this? Right. Minus 1 will have last two digits 0. So plus 1 will have. So in fact, last two digits of this expression is 0, 1. Right. Is 0, 1. So all zeros plus 1. Right. So is 0, 1. And if you remove minus 1, it is becoming 0, 0. If you do plus 1, it will become 0, 2. Right. So last two digits of this one will become 0, 2, because whatever one extra is there that we are removing, so it will become in two zeros. Now 1 plus 1. So 0, 1 plus 1 will become 0, 2. So last two digits will become 0, 2 in this expression. Right, guys? Hope you understood this. Thank you. This is a basic binomial expansion only. Just that we should not get worried by just looking at 11 power 10. We should look at it as 10 plus 1 whole power 10. Right, yes. Thank you.